Alright, so this is the fourth video of the unit. It's over solving by using the quadratic formula. So basically we're going to do this if we try factoring and it doesn't work, if we try square root and it doesn't work, and completing the square would not be a good idea. The quadratic formula will always work. Alright, so first I'm going to pause this and write the quadratic formula. Alright, so the quadratic formula is over here. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And in class today we discussed the discriminant. So hopefully b squared minus 4ac looks familiar. So from my equation I have a equals 2, b equals negative 3, and c equals negative 2. So the quadratic formula, negative b, so it's negative 3, plus or minus the square root. I'm just going to plug in a, b, and c into my formula. Plus or minus the square root of b squared minus 4ac. And it's divided by 2 times a. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So here negative 3 out front is just positive 3. Negative 3 squared is 9. 4 times 2 times negative 2 is negative 16. So I have minus negative 16 all over 4. And that's 3 plus or minus 9 plus 16 over 4. And then 9 plus 16 is 25. The square root of 25 is 5. And then quadratics have two answers. So I have 3 plus or minus 5 over 4. So I have 3 plus 5 over 4. And three minus 5 over 4. Oops, and negative 1/2, so that says it in there. So with the quadratic formula, it's boxed in navy blue. Then you just plug in a, b, and c into the formula and start simplifying. At the very end, you have 3 plus or minus 5 over 4. That's two different answers. So we have 3 plus 5 divided by 4 and 3 minus 5 divided by 4. So my final answers here, my x-intercepts or my roots or my solutions would be x equals 2 and x equals negative 1/2. All right, here's one with giant numbers, just to show you that we don't have to be scared of giant numbers. So we have a equals 16, b equals negative 40, and c equals 25. So we have negative b, so we have negative 40 plus or minus the square root of b squared minus 4ac divided by 2a. And we have negative 40. So that's just 40 plus or minus the square root. Negative 40 squared is 1600. And then 4 times 16 times 25 is 1,600, and that's divided by 32. So I end up with 40 plus or minus the square root of 0 over 32, which is 40 plus or minus 0 over 32, because the square root of 0 is in fact just 0. So then it's 40 divided by 32, which we can divide both of those by 8. So divide by 8. So that's really just 5 over 4. So we talked about this on Friday, that if we get a discriminant of 0, that means we'll have one real solution. And in this case, that one real solution is 5 over 4. So again, just identify A, B, and C, plug them into the formula, work out the formula. Quadratic formula may seem tedious or boring or a lot of work, but the work will always be the same, and we'll always be able to get an answer. Sometimes when we factor in stuff, it won't be factorable. All right, last one. So A equals 1, B negative 6, C 10. So we have negative 6 plus or minus the square root of negative 6 squared minus 4AC divided by 2A. And negative 6 is 6 plus or minus the square root of 36 minus 40 all over 2. Then we have 6 plus or minus the square root of negative 4 over 2. Okay, so we've ran into a negative square root, which is not good. So on Tuesday and in class today, we talked about discriminant. So the square root of negative 4 is just I times the square root of positive 4. So when you have the square root of a negative number, just turn it to positive and put an I out front. So 6 plus or minus the square root of 4 is 2, so it's 6 plus or minus 2I over 2. Then, if you look, I can divide that by 2, and that by 2. So this actual answer would be 3 plus or minus I. So 6 divided by 2. 6 divided by 2 is 3. 2I divided by 2 is I. So my actual simplified answer would be 3 plus or minus I. So if we have a positive discriminant like the first example, we'll have two real solutions. If we have 0 as a discriminant, like the second example, we will have one real solution. And if, like in this example, we have a negative discriminant, or a negative underneath the radical or underneath the square root, we will have two complex solutions, or two not real solutions. All right, so there's a quadratic formula. Identify A, B, and C, plug it into the formula, finish the work.